Hello everyone. All right, in this video we're going to be continuing with the week 3 notes where we left off, which is on page 26. So the first thing you see on page 26 is this percent decimal fraction conversion table. So the way that we're going to complete this table is by using all those notes that I wrote off to the side, which we'll go over in a second, but ultimately you need to know how to read this table. So if you look at this first box, it gives you a fraction of 1/10. What you have to do with that is convert that fraction to a decimal, and you're going to place that answer underneath the word decimal, and also convert that to a percent and place that underneath the percent section. And then that kind of goes throughout the whole table. You'll notice sometimes you're given a decimal, sometimes you're given a percent, and you just need to be able to convert all around. So that's what these notes off to the side are explaining. Whether you want to go from a fraction to a decimal to a percent to a decimal to a fraction. There are a couple other ways of converting, but ultimately that's all you need to be able to jump back and around to different types of fractions, decimals, or percents. So starting with the first one, which is 1/10, if you go off to the side, the first bullet point says fraction to decimal. To convert a fraction to a decimal, you just have to divide it in your calculator. So I'm going to open my calculator. And the first fraction was 1/10. So you type in 1 divided by 10 in your calculator, and it will give you 0.1. It automatically converted that fraction by using division to a decimal. So on my table, I'm going to type in, underneath my decimal, 0.1, which is the same as just 0.1. So if you prefer to just have that 0.1, it's perfectly fine. Okay, the next bullet point says decimal to percent. To convert a decimal to a percent, you just have to multiply the decimal by 100. So we already have our decimal as 0.1. I'm just going to scoot back to my calculator. Because I already have the 0.1, I'm just going to type it back in. All I have to do is multiply it by 100, and that will get me 10. So 0.1 is equivalent to 10%. Okay, the next one I'm going to draw your attention to is actually down here. 30% goes along with this highlighted one, and I highlighted it and started because this is the most important conversion you need to know. It's going the opposite way. So we just went from a decimal to a percent, in which case we multiplied by 100. This one, for a percent to decimal, you're going to do the opposite and divide the percent by 100. So the green that I circled right here, 30%. If I want to convert that to a decimal, which I have to for this table, all you have to do is take 30 and divide it by 100, and it will get you 0.3. So I'm going to write 0.3 in the corresponding box. And then there's a shortcut that I'd like you to notice, and I noted it on here, but we didn't really talk about it yet. So for going from a decimal to a percent, you want to multiply the decimal by 100, which we talked about, or you can move the decimal point right 2. And then going the other way, percent to a decimal, you want to divide the percent by 100 like we just did, or move the decimal point left 2. So notice with this decimal, I could move it 1, 2 places to the right, fill in this blank with a 0, and you end up with 10%. Or if you go with the 30%, it has a decimal point at the end. Every number has an imaginary decimal point after it. If I move it 2 places to the left, I get 0.3, which is exactly what we have right here. Okay, so whichever way you want to memorize it is completely up to you. You can either remember to multiply or divide by 100 or to move the decimal point. So something that's nice with the remembering to multiply or divide method is when you're working with this one. And again, that's the most important one, percent to decimal. So I'm going to go over that and why it's easy to remember right now. So dividing your percent by 100. If you think about things where you have the most experience with percents, I'd have to say it's probably tests. And test scores are out of 100. Percents are all out of 100. So like let's say you get an 80%. That means you got 80 out of 100. If you get a 100%, you got a perfect score because you know that's 100 out of 100. So if you have a percent, like 30, you know that that's technically out of 100. So to get the decimal version of it, you just divide it by 100 to get there. Okay, and then the last one we have to go over is the very, very last one on the bottom, which is a decimal to a fraction. So I'm going to go back up to where I skipped right here to go from a decimal to a fraction. There's an operation on your calculator that will do this for you. So I'm going to jump over to my calculator to convert 0.2 to a fraction. I'm going to type in 0.2, like it says, type decimal into calculator, and then it says to press math, enter, enter. In doing that, that 0.2 is going to become a fraction. So I'm going to go to my calculator. I'm going to hit 0.2. The math button is right here. And then you're going to press enter, enter if you have the actual calculator. I haven't actually done this yet on my app, but you can do math and then choose 1 and then enter. See how it turns it into a fraction? So I'll show you again, 0.2. You can hit math. Usually you can just press it and press enter, but apparently on this app, sorry, you cannot. But if you read choice 1, it says take that value and convert to fraction. It directly tells you what you're doing. So math choice 1, enter. And notice that gets you a fraction. So that 0.2 is going to convert to 1/5. So over here underneath fraction next to 0.2, I'm going to put 1/5. Okay, another way that you can convert from decimals to fractions, if something that you're more familiar with, is the way that this 0.2 that's circled in purple is red is 2/10, because it's in the tenths place after the decimal point. Remember, it goes tenths, hundredths, thousandths, and so on. So because that 2 is here, it's in the tenths place, which means it's 2 out of 10. And if you remember simplifying fractions, you can divide the top and the bottom by 2, and you'll end up at 1/5. It's just another way. Obviously doing it in the calculator is probably a lot easier, but if that's something you're more familiar with, absolutely do that. And then just a quick little review to go from decimal to percent. It's the opposite of percent to decimal, so I'm going to multiply by 100, and 0.2 times 100 is going to get me 20%. Okay, so what I'd like you to do is pause the video at this point and fill out the rest of this table using the information given on the right. Okay, so hopefully you're pressing play and returning. So I'm just going to fill out the rest of this table real quick so you can check it along the way. So you notice that there was a pattern here for the most part. I'm hoping you felt pretty confident about that, especially ones that are more familiar. Okay, but just take a second to check over your work, make sure you did all of these correctly. Okay, some that might have been more familiar and easier to you were probably like 1/2 is obviously 50%, because 50 out of 100 is half. 0.5, if you want to think about it like money, is like 50 cents, which is half of a dollar. That's always a nice way of looking at decimals for sure. 3/4 is otherwise known as 3/4. That's 75%, or 0.75 when you scoot that decimal point 2 places to the left. There's a lot of different ways of converting all of these. So hopefully filling out this table helped you to kind of understand going from one to the other and all around these conversions. But do remember that this one right here, percent to decimal, is the most important. So we're going to use that in the next couple of examples. All right, so moving right along to number 119, part A, doing some more word problems. It says, if the bill for a meal for 5 people came to $27.89 before it was taxed 8%, how much will they be spending on tax alone? And then what is the new total bill? So let's work on just tax alone to start. Oops, I'm going to do that over here. Okay, so the total bill was $27.89, and it's being taxed 8%. To find how much the tax alone is, that means you need to figure out what 8% of $27.89 is. To take a percentage of a number, big life skill. To take a percentage of a number, the first thing you have to do is convert it to a decimal. So you can go back and read your notes, but remember, percents are out of 100. So I just need to divide this by 100 to convert it to a decimal. And in my calculator, 8 divided by 100 is 0.08. So to find 8% of $27.89, I'm going to take the $27.89 and multiply it by the decimal version of 8%. That's how I find 8% of $27.89. So you're definitely going to want to plug that in your calculator. Just hit the multiplication and you should get 2.2312. We are talking about money here. This is the tax on this bill. So tax needs to be rounded to the nearest hundredth because it's money. So hundredth is 2 places after the decimal point if you're unfamiliar with the verbiage, but it's essentially just the way you would round money. So I want my money to have these 2 places, but you still need to reference that third place, 5 or above. Give it a shove. If you need a review on rounding, I'm going to attach a rounding video a little bit later, so you can check that out if you need to, or you can just check it out yourself on YouTube because there's rounding videos everywhere if that's something that's unfamiliar to you and you need more help with it, or you can come to office hours anytime. Okay, so 2.23, and then that 1 does not have enough power to bump that 3 up, so it's going to stay $2.23 for the tax alone. So that answers the first question. The second question is, what is the new total bill? So the new total bill with that tax added on to the $27.89 is just going to be the total you get when you add those 2 things together. So I'm going to take the $27.89 and I'm going to add it to the $2.23 that the tax is. And when I add those together, I get $30.12 as my total bill, tax included. All right, part B, with this same bill of $27.89, the 5 friends want to leave a 20% tip before the tax is added in. So ignore this $30.12 number for now. This is talking about before the tax is added in. So we're just going to use the $27.89 number. It says, how much money do they need to leave as a tip? So it only wants the tip alone, which is 20%. So that means I have to find 20% of the bill amount. So 20%, first I need to convert that to a decimal. This is just like the last problem. To convert a percent to a decimal, you divide it by 100, and that's going to give you 0.2. Okay, so just like we did before, take that $27.89, but this time we're going to multiply it by 0.2 or 0.20 to find 20% of that number. So take a second to plug that in your calculator. Just get familiar with your calculator. You should get 5.578. If you need to pause to take more time, absolutely do so. But I definitely want to get ahead and round this. So I want it rounded to the nearest hundredth because it's money still. But I need to reference that third digit in the thousandths place to see if it bumps it up. 5 or above, give it a shove. This one is 5 or above, and 8's higher than 5, which means it's going to shove that 7 up to an 8. So the tip is going to be $5.58. Not because this was an 8, but because the 8 bumps the 7 up. And that answers the question. This one wasn't asking about the total bill as well like the last one. It just wanted the tip, so we were done. Okay, now part C, very basic math question. It says if they want to split this tip 5 ways, how much would each person have to contribute towards the tip? So the tip was $5.58. If they have to split that 5 ways, you're going to take that amount and just divide it by 5 different people to see how much each individual person would have to pay. So $5.58, and I'm just going to divide that by the 5 people. Again, you can plug that right into your calculator. You get 1.116. I'm again going to round that. I want it rounded to money, so the nearest hundredth. But I want to reference that third digit, 5 or above, give it a shove. This is going to round up to $1.12 per person or each. Now I know that's unrealistic. If you're out to dinner with some of your friends, you're not going to take out 12 cents and dig in your pennies, but that's just the logic behind, being perfectly even. Okay, so now we're going to dig into some tougher examples with percents. So we're going to get into this mortgage example. It's a really fantastic example. I imagine most of you, if not all of you, will have a mortgage at some point in your life. You're probably not going to pull out these math notes and reference this mortgage formula, but it just gives you an idea of what kind of things are considered when coming up with like monthly payments for mortgages and stuff like that. So this mortgage formula is what we're going to use. It's not like the mortgage formula, but it is one of very many to calculate a monthly payment based on, how much a house costs or what your interest rate is and how long you're paying for it and all those different things to consider. So what's nice about formulas like this is if you look off to the side, it also gives you what each of the variables in the formula stand for. So if we know what they stand for, we're able to plug those numbers in for the given variables. So P in this formula represents the principal amount of mortgage. If you don't like the word principal, it just means the starting amount of the mortgage. So essentially what the house is worth. Okay, next it states R. R is your monthly rate. Make sure you take note that it's monthly. We'll talk about that once we get in the problem. But monthly rate needs to be put in your formula as a decimal. So an interest rate is going to be given as a percent, but you don't plug in your percentage. You always plug given percents into problems or into formulas as decimals. So we just went over how to convert them, and we'll work with that once we get there as well. Okay, M stands for your monthly payment. Notice M is the thing that we are solving for. It's all by itself on the left side of the formula. We're going to plug into the right side to figure out what the monthly payment is. And then the last thing on here is N, which stands for the number of payments it takes to pay off the loan. All this information, like I said, is going to be given to us. So we're just going to go through and figure out what all of those are for this first problem, which is 120A. So it says for this problem, calculate the monthly payment needed to pay off a $200,000 loan at 0.3% monthly interest, which is about 4% annual interest over a 20-year period. Recall that R is the monthly rate. Show your work and carefully evaluate the above formula for M monthly payment. So the problem's even telling us we need to just plug in the formula to find M. So M is the thing that's not given. It's your unknown. This is what we need to find. So if that's what we need to find, then we need to plug in for the other variables, which is P, R, and M. So we need to know what P, R, and M, or not M, sorry, N, are. Now recall, P stands for the starting or the principal amount of the mortgage. So if you look back in the problem, how much is this mortgage worth? That's going to be $200,000. Okay, R is the monthly rate. There are 2% here. There's 0.3% and there's 4%. Make sure you look at the monthly rate. Do not let that throw you. 0.03 is the monthly interest. Or sorry, 0.3. So 0.3% is the monthly interest, but if you go back up, remember that needs to be given as a decimal. Now, this might seem kind of confusing, and we didn't do any like this yet, so stick with me. I know it says 0.3%. There is a decimal right there, but because it has this percent symbol, that means it's in its percent form, and percents are out of 100, so this is really 0.3 out of 100. That's what that percent symbol means. It means out of 100. So to convert it to its decimal form, even though it's already a decimal, it's not in its form, it's still a percent, we need to divide it by 100. Okay, so 0.3 divided by 100 is going to be a very tiny number. It's 0.003. You can either divide it in your calculator or use that shortcut and scoot the decimal point left 2 places. That's where those 2 zeros come from. Okay, so all this is just work to get what R is. R is 0.003. I'm going to leave that work there, but I don't want it to confuse you. This is what R is. Okay, and then N is also a little bit tricky. It's the number of payments it takes to pay off the loan. So if you look through the problem, there's only one more number that we haven't worked with yet, and that is this one right here, over a 20-year period. Now, N is not 20. I'm going to read it again. N is the number of payments it takes to pay off the loan over a 20-year period. You're not making 20 payments. You're making 20 years of monthly payments. Think about what that means in terms of what N needs to be. 20 years of monthly payments. How many total payments would that be? Okay, there are 12 months in 1 year. But if you multiply that by the 20 years you are making monthly payments, that's going to get you 240 monthly mortgage payments. Okay, so that's the math you have to do to figure out the number of total payments. Take the 12 months you know that there are in a year and multiply it by how many years you're going to be making those 12 yearly payments. Those 12 monthly payments. Sorry, I said that wrong. Okay, so now that I know what those are, I can plug them into my mortgage formula, which again is in that blue box at the top. So I'm just going to zoom in a little bit here. And I've got M equals. The first thing I have on the top of the fraction in the formula is P. So I'm going to plug in P, which is 200,000, times R. So times R is 0.003. And that's it for the top. All right, now on the bottom, I have 1 minus parentheses 1 plus. Notice I didn't plug in anything for variables there. I just brought down that part of the formula, but then I hit a variable in the formula. The next thing is an R. So I need to plug in R right here. So even though we already plugged it in once, we have to plug it in again. Then I notice in the formula the parentheses end, so I'm going to close my parentheses, and I know it's kind of small, which is why I'm just going to zoom in even more. Notice that up here in the exponent is a negative n. You need to bring that negative with you in this formula, so it's going to be negative, and n is 240. Okay, so something else we haven't really worked with is simplifying something using PEMDAS that's a fraction. When you have a fraction and you're using PEMDAS to simplify, you use PEMDAS on the top and the bottom separately. So I'm going to PEMDAS the top first, which is very, very easy because it's just multiplication. It's 200,000 times 0.003. So I'm not even going to bring up my calculator for that. I'm just going to have you practice plugging it in. 200,000 times 0.003 should get you 600. And you're done with PEMDAS and all your simplifying on the top. It was just multiplication, so the top is good. The bottom, however, has a lot more involved. So if you look at the bottom, you're going to start with P, which is your parentheses. So I'm going to make this a little bit easier on you rather than plugging that into my parentheses or into my calculator. I'm going to do what's inside the parentheses in my head. It's just 1.003. No harm if you plug it into your calculator at all. Okay, I just took care of P, which is parentheses. Next is exponents, so I have to plug this into my calculator, and that I'm definitely going to show you. So grab your calculator. Okay, we have parentheses, 1 plus 0.003, or sorry, 1.003. I forgot we already simplified that. And you're going to raise that to the negative 240. The negative button is not the same as your minus, and I'll say that again because it's so important. The negative button is not the same as your minus. Negative is down at the bottom by 0. That's your negative. And then 240 equals. Yes, it's an ugly number. Yes, we need to write down that whole ugly number, at least the first like 6 digits or so. Okay, so again, to get that, I did my parentheses, 1.003. To get up to the exponent, I hit this little caret button by the clear, and then use the negative button, 240 equals. All right, so that just goes where my green box is. So this is going to be m equals 600 on top, and then it's 1 minus, again, like I said, just do at least like 6 digits or so of it. You can't just write like 0.4. That will mess with your whole answer. The more decimals you have, the more accurate your answer is going to be. Okay. I think I copied that right. Yeah, that's plenty. Okay, now we are almost done with PEMDAS on the bottom. All we have left is subtraction, so you're just going to plug that in. 1 minus 0.487277. Remember, don't just do 0.4 or 0.48. You've got a lot more decimal than that. Okay, so 1 minus 0.487277 is going to be 0.512723. And we are done PEMDASing the top, and we are done PEMDASing the bottom. I just turned it into a verb. So now that we have one number on the top, one number on the bottom, you can just divide them to get your final answer. So 600 divided by 0.512723 is going to be equal to our answer, which is 1170.222518. Just so you all know, I have all of these rounded to like 6 decimal points. So if mine rounds it a little bit different and your digit's like 1 off or so, it's absolutely fine. You know, it doesn't say what to round to, but remember, this is money. So just like that last page we worked on with tax, tip, and percents and everything, we're going to round it like money, which is 2 decimal places, but you need to refer to that third place, 5 or above, give it a shove. That 2 will not round that up. So our final answer is going to be $1,170.22 per month. That's the monthly payment if you were to have all of these scenarios. So it's a 20-year period, 0.3% monthly interest, and a $200,000 loan. So if we look at part B, it says, what if the payoff period was 30 years instead of 20? Determine the new monthly payment. So a couple of things aren't changing here. It's only changing the 20 years to 30 years. What letter did that have an impact on? I'm asking you like you can answer me. The years involved in this problem only has to deal with the variable n. So P and R are going to stay the same. So P is still 200,000. and R is still 0.003. N is your new total number of payments. Remember, N is the number of payments it takes to pay off the loan. So if we're changing that from 20 years of monthly payments to 30 years of monthly payments, that's going to be 12 times 30 to find out how many total monthly payments that will be, and that's going to get me 360. So before even jumping into this problem, try and think logically about this. If it's the same cost of the house and the same interest rate, nothing else changes except for how long you're making these payments, are the payment amount each month, so this number up here, is that number going to increase or decrease if you're paying it off for a longer period of time? Okay, hopefully you said decrease. It's taking that same amount of money, actually a little bit more because you're paying longer for interest, but it's dividing it by an extra 10 years. So it's going to make your monthly payments decrease. Okay, so what I'd like you to do is actually pause the video right here and try and do this whole process that we did up here completely on your own in your calculator. Use PEMDAS and just be careful. Good luck. Okay, so if you're coming back, hopefully we're plugging this in, so I'm just going to plug it in with you real quick. So 200,000 times 0.003. That was all the same on top. You could have even just brought down the 600. This is 1 minus 1 plus 0.003, but now it's to the negative 360. So this will be 600 on top, like we just said. That didn't change. This is going to be 1 minus, remember this right here is just 1.003. I'm not going to rewrite that step, especially since you've already done it on your own. But when you plug in the 1.003 to the negative 360, that should get you 340,145. Okay, then you need to subtract those on the bottom to finalize your last step in PEMDAS, and when you subtract those, it'll get you 0.659855. And remember, your digits might be a little bit off. I had my calculator just round it to 6 places after the decimal point, but you should be good. Even if you did more decimals, that's even better. Any less, I don't recommend it. Do as many as you can to be as accurate as you can. Okay, and then when you divide those two numbers, you should get 909.290677. Hopefully you got that as your answer. But when oh no. I was trying to avoid hitting that. When you round that number to the nearest hundredth for money, that means you're going to look at this third digit. The 0 is not going to bump that 9 up. It's 5 or above, give it a shove. So 0 doesn't have enough power. That means our final monthly payment is going to be $909.29. Okay, if you did not get that or you didn't even get anything close to that, absolutely please email me or please meet me during office hours and I can walk you through those steps. But something worth taking note of, in this one specific example with this interest rate, this price of house, this mortgage, and then the amount of time. Notice for 20 years, the payment was $1,170 per month. To pay for an extra 10 years, it only went down to $909. The reason for that is because of your interest. You're being charged interest on those extra 10 years as well. So definitely, I think if you have the money available in this one specific scenario, doing it over a 20-year period rather than getting that extra 10 years of interest would absolutely be beneficial to you. All right, let's move on to the next page. Okay, we're going to jump back to that process of solving equations, but we're going to work with inequalities. And before we do that, I want to go through this table with you to talk about what inequalities even are. So an equal sign we've talked about so much so far, like x equals 2, that means the answer is 2. If you have inequalities, that means your answers are either, if you look at these options right here, could be less than, greater than, less than or equal to, or greater than or equal to. So that's really a big variety of possibilities, but like, let's say this first one is x is less than 2. Okay, x is less than 2. I just made up a number. That means any of your answers could be numbers less than 2. Your answers include 1, 0, -1, -1,000, -1 billion, positive 1.5. There are infinitely many numbers that are less than 2. So inequalities can get you infinite answers, literally countless solutions. So if x is less than 2, I'm going to show you what that's going to look like on a graph to kind of show all of those numbers. I'm just going to put some reference numbers around it. So to the left would be 1, 0, -1. And notice the circle is already on there. It's an open circle, which I'll explain to you once we get a little bit further, but it just means that it's not equal to. Okay, but I do want you to shade in the less than direction. This is what the graph of x is less than 2 would look like. Okay, now your less than symbol. I'm going to try and explain this to you as best as I can over this video. Okay, so less than is going to be this symbol. You have to recognize that symbol. If you look at the next few examples, they have the symbol, but it doesn't give you the words as well. You just need to know what those symbols represent so that you can actually answer the question when needed. So you need to know that that symbol that I circled in red is less than. If it helps you, less than starts with L. I want you to take your left hand and make an L. I'm sure you've done it before, but with your pointer finger and your thumb, it would look like an L. If you turn your hand a little bit, your pointer finger and your thumb, it looks just like a less than symbol. Okay, so it's just a little helpful tool for you, which is obviously a lot easier to show you in person. But if you just put up your pointer finger and your thumb, put the rest of your fingers down and create an L, L for less than, using your left hand. If you turn it to the side, like this image here, it turns into a less than symbol. So that's a really easy way to help you remember that that's less than. Another way is like the alligator trick, which I'm sure many of you have seen before. If you have a less than, I'm just going to use 2 numbers completely out of the blue. We know that 2 is less than 5. People say that this is a Pac-Man or like an alligator mouth, and the mouth is open towards the bigger number because it wants to eat more. So I know these are kind of silly examples. The next one is a greater than symbol. So like 5 is greater than 2. Notice now the mouth is open towards the bigger number on the left. That's why that symbol is greater than, whereas this symbol in the first example is a less than. So just a couple helpful ways to help you remember, or you can just memorize the symbol if you don't already have them memorized. So let's move on to the next one. We're going to do a greater than example, and I'm going to have you use a negative number. So let's say that x is greater than -5. Your -5 is going to go in the middle of your number line, but be very careful about your numbers around it. So the next number bigger than -5 is -4, -3, -2. When you're going towards the left, that's where your numbers are getting smaller, -6, -7, -8. So it's an interesting concept that a lot of people struggle with, but try and think about it like money. I reference money a lot because it's something we're all very familiar with. If you have -$5, that means you owe somebody $5. If you have -$8, that means you owe someone $8. Owing someone $8 is less money, like you personally having less money, than owing someone $5. Whereas if you owe them $2, it's more than owing someone $5. Like you have more to your name than if you're in debt more. Like the more negative your number is, the more in debt you are. So that's a smaller number. Okay, now this symbol is a greater than. So the numbers that are greater than -5 are going to the right. So we're going to shade the number line to the right to represent the infinitely many numbers that are greater than -5. And I have no fun way with your hand to show greater than. It's just the opposite of your L left hand less than symbol. All right, now here's the difference with less than or equal to, and I'm going to show you with the same numbers. So these same numbers on the number line, it's going to be 2, 3, 4, 5, 1, 0, -1. No difference there. Okay, it's still shaded to the left to show that it's less than. So if you notice, the 2 less than examples have really, really similar graphs. The only difference is the circle. Here it's open, and for or equal to, it's closed. Why? So the reason for that is if I say something is less than or equal to 2, that means it could be 2. Less than or equal to 2 includes 2 in your solutions. Whereas this one, just being x is less than 2, means 2 is not included because 2 is not less than 2. I know I just said 2 a lot. It's an interesting concept, but 2 being less, or x being less than 2 means it includes only numbers that are smaller than 2. But x being less than or equal to 2 means 2 or lower. So to represent that on a number line, you continue your shading over that number that it's or equal to. It's kind of the same thing with the next one. Let's do -5 again so we don't worry about labeling this. I knew I was going to do that. My hand just gets over there and it bumps the side. I told you that before. I'm so sorry it happens so often. -3, -2. There we go. And this one is a greater than, and my numbers greater than -5 are going to shade to the right, but it is greater than or equal to. So kind of that same concept I just went over with you, where it says greater than, you shade to the right. So these number lines are very, very similar to each other. The only difference being the same thing we just talked about in the last one, that -5 has a closed circle over it. Okay, so this one is closed, closed circle. This one is open, and this one is open. That open circle represents that for this one. X being greater than -5 means all the numbers bigger than -5, not including it. And then this down here for x is greater than or equal to -5 has a closed circle because it's like -5 or higher. It includes that -5 in your solution because of the or equal to. Okay, so those are your symbols. That's how you want to graph them when that comes up, and we will be doing that in the next few examples. And these symbols over here on the left, you must memorize. Okay, so whether you use the L or the alligator trick, whatever it may be, you've got to have those memorized. And so moving on to the bottom with solving inequalities. So what's kind of nice about solving inequalities is hopefully you're at least looking at these examples and noticing they look a lot like that basic form for solving an equation. You're going to use the exact same rules as you would for solving an equation. But there's one additional rule you must know, and it's starred on here. When you multiply or divide by a negative number, you must flip the sign. Okay, you must flip your sign, and the sign that I'm referring to is the inequality sign. Your less thans, your greater thans, whatever it may be for the specific situation, those are the signs that get flipped if you are multiplying or dividing by a negative number. So you'll see what I mean when it comes up, but other than that rule, you're solving inequalities like you would solve any plain old equation. So let's jump into number 121. Your goal is to get x by itself, and you always have to get rid of what's being added or subtracted first. So you're treating this like an equal sign. So it's the same kind of thing. If you want to draw on that line, absolutely go for it. But to get rid of what's being added or subtracted first, that would be the +4, and I get rid of it by doing the opposite, which is -4. So that 3x comes down. Rather than bringing down an equal sign, you bring down the inequality symbol that's given, and then 16 minus 4 is 12. Okay, x is still not by itself. I have to get rid of that 3 by dividing by 3. Remember in your head, if you divide by a negative, you flip the sign. This one, I'm not dividing by a negative, so the sign's going to stay. So that x comes down, the greater than or equal to comes down, and 12 divided by 3 is 4. Now notice in the directions it says to solve and graph the following. So I need to put that on a number line graph just like we saw above in the table. So I'm going to draw a number line. The most significant number here is 4, so I'm going to put that in the middle with some reference numbers around it. Now, every time you're graphing an inequality, you want to ask yourself two things. First, is it open or closed circle? And then do you shade left or right? Okay, to determine if it's an open or a closed circle depends all on that. If it has the or equal to, it's going to be closed. This one does have an or equal to, so it's going to be closed. So I answered that question. Then it's left or right. So you need to determine what the symbol is. That is a greater than or equal to symbol, which means you're going to shade where it's greater than or equal to 4. So that's going to be shaded to the right, where numbers are greater than or equal to 4. I have the or equal to because I closed that circle. So your answer to the problem is this right here. X is greater than or equal to 4. What that means is your answer could be 4, 4.1, 4.5. It could be 7. It could be 12. Any number bigger than or equal to 4 is a solution to this inequality. So this is a little bit harder to check, but it literally means any number 4 or higher could be plugged in right here and it would work in this inequality. So you can check a 4, you can check 5, you can check 12. There's infinitely many numbers you can check, which is why checking is a little weird for inequalities, but it should work if you plug in any number 4 or bigger. Okay, next one is 123. Yep, I'm gonna go out of order here. We're gonna skip 122 for now, and I'm just gonna move over here to 123. Okay, so it's still in that basic format. It's a little out of order, but it's the same essential steps for solving an equation. So this is a less than symbol. Okay, so I'm just gonna draw that line. You don't need to, but you always get rid of what's being added or subtracted first. In this case, the -2 is being multiplied to the x. So the thing that's being added or subtracted is the 7. So to get rid of that +7, I'm going to subtract 7 from both sides so that the -2x comes down. Make sure you bring down a less than symbol. I know you're probably used to equal signs by now. And then 11 minus 7 is going to be a +4. Okay, x is almost by itself. It's being multiplied by -2 right now, so I'm going to divide both sides by -2, and hopefully you're hearing what I just said and like thinking like a big red flag, dividing by a negative. Big red flag. When you are solving an inequality and you divide by a negative, you have to flip the sign. Okay, so here's an example of what that looks like. Right now we have a less than, but because we're dividing by a negative, I have to flip that. So now it's going to be a greater than. Okay, when I continue solving this, these -2's cancel and just leave me with x, so I'm almost done. 4 divided by -2 is a -2. So that's your final answer, but we also have to put it on a number line. So the most significant number here is a -2, so that goes in the middle. And then I need some reference numbers. The next number bigger than -2 is -1 and then 0. Smaller is -3 and -4. I know 3 and 4 are bigger than 2, but when you have a bigger negative value, it has less value. Okay, now remember those two questions you have to ask yourself. First, is it open or closed? Our symbol here is a greater than. It doesn't have the or equal to. That means -2 is not included. It's not equal to x. All that's included in the solution are the values greater than -2. So I have an open circle and I shade to the right where my numbers are greater than. Something that is a nice little trick if you're at all interested. I know everyone usually loves tricks. See how the greater than is pointing to the right? That means shade to the right. See, this one also, greater than or equal to, is pointing to the right. That means you shade to the right. Okay, up here, I'll just go back and reference a less than. This one was a less than. It was pointing to the left. We shaded to the left. It's a really nice trick. If you don't want to really remember if it's a less than or greater than, you should try and memorize those signs, but that will definitely always work as long as you have it in this format where it's x is less than, x is greater than. If you have 5 is greater than x, it's actually saying that x is less than 5, which we're going to get into in a minute here. It's like reading it vice versa. Okay, but you can only use that it's pointing to the left, so I shade to the left rule if you have the x written first. If you have it written as the other way around, like 5 is less than x, for example, you can't shade it to the left. Okay, before we get into the next example, I do want to show you one thing about this dividing by a negative and why we actually flip the sign. So I'm going to make up another inequality, just pulling it out of thin air, and say that 1 is less than 5. I hope we all agree that that is true. Okay, 1 is less than 5. If I divide both sides by an arbitrary -1, just to show you why dividing by a negative flips the sign. Oh gosh darn it. Almost there. Okay, back to it. I'll try to not do that again. On the left side, this right here, 1 divided by -1 is a -1. And over here, 5 divided by -1 is a -5. If I bring down that less than sign without flipping it, this is not true anymore. -1 is not less than -5. It's greater than -5, which is the reason you need to flip the sign. People ask me all the time, why? That's the reason why. Okay, when you divide both sides by a negative, it negates the value and therefore makes the flip-flop, like it makes it the opposite. So another example that might actually be easier to understand, and I probably should have started with this one, but we live and we learn. Let's say -2 is less than a +4. Okay, this one might help you if you didn't really understand that. I'm still going to show just dividing by a random negative number. But see on the left side, when you take a negative and you divide it by a negative, it becomes a positive. On the right side, when you take a positive and divide it by a negative, it becomes a negative. See how that sign doesn't apply anymore? Oh man, I'm so sorry. Here we go. A positive is no longer less than a negative. See, the point and the reasoning for needing to flip the sign is because negating it kind of like opposites your values. We had a negative here, now it's a positive. We had a positive here, now it's a negative. They flip-flop when you divide by a negative, and that's why your sign needs to flip-flop as well. Okay, one more thing before getting into the next example is your code word off to the side over here. Your code word for the week 3 part 2 video is going to be cookie. Okay, so make sure you write that down somewhere so you can put it on your week 3 homework quiz. And we're going to move into these last 2 examples. So 122 is rather difficult, and I will tell you right now, you really won't see something like this on a test or a quiz. Okay, but if you read through it, you'll see why it's kind of tough. So it's -9 is less than x minus 10 is less than or equal to -5. There are 2 inequality signs in the same problem. But remember, your goal is to get the variable by itself, no matter what. So typically, what you're told is what you do to one side, you have to do to the other. To get rid of this x, what I first want you to do, don't actually write this, but pretend this isn't here. Cover it up with your hand or something. If you were solving just one piece of this inequality and you had to get the x by itself, you would get rid of that -10 by adding 10 to both sides. And we usually say both sides. But in this instance, that piece is still there and it's another side because you have 2 inequality symbols here. You'll see why this is written out so weird in a minute. Okay, but there's 3 different portions of this inequality, so you have to add to all of them. So on this left side here, -9 plus 10 is 1, and then you bring down your less than symbol. Notice here that -10 plus 10 cancels, and it just leaves you with an x. And then the less than or equal to comes down, and -5 plus 10 is a +5. X is by itself. When x is by itself, you have your final answer. So this is actually your answer. So take a second to read that from left to right. It's 1 is less than x is less than or equal to 5. It's giving you 2 different things about x. So x technically still has infinitely many answers for this, and we'll talk about that at the very end here. Okay, but it's telling you that x falls between 1 and 5. If you want to rewrite this to help you understand it, this usually makes the light bulb go off for people. There's two inequalities here. The first one is this. That one's the easiest one to read. X is less than or equal to 5. Okay, but there's also another inequality here where that x is used twice. It's just trying to write it out easier for you. So here's where that backwards thing comes into play. 1 is less than x is our other inequality, but we don't want it written like that. It's kind of hard to understand. So 1 is less than x is the same as saying that x is greater than 1. Notice how your symbol still opens up towards the x, so it says the same thing. And usually this example helps too if you want to think about it as I am older than you. That's the same sentence as you are younger than me. When you flip-flop them, the words older and younger kind of are telling you the same thing. Just like less than and greater than are telling you the same thing when you flip-flop the order of these terms. So again, I am older than you, you are younger than me. They're the same sentences, they're just written flip-flopped. They have the same meaning. So essentially our two inequalities within this one big inequality is that x is less than or equal to 5 and x is greater than 1. Okay, so let's see what that looks like on a number line. In this situation, we have two significant numbers, 1 and 5. So I'm going to put my numbers on here, including 1 and 5. Okay, just make sure you have 1 and 5 somewhere on your number line. And you're just going to graph each of them. So x is less than or equal to 5 is the first one I am going to graph. So remember the two questions you need to ask yourself. First, open or closed circle. A less than or equal to is going to have a closed circle because it's equal to 5. It's included in the shading. And less than is shaded to the left. Don't get carried away with the shading yet because I'll show you why in a minute. Okay, but I know it needs to go to the left. Let's graph the other one. X is greater than 1 does not have a closed circle. It's not included, so that's an open circle around the 1. And greater than means it's shaded to the right. So this inequality needs to meet both of the standards, being less than or equal to 5 and greater than 1. So they both work shading in between them. So think about the numbers that would work for this. Being bigger than 1 and smaller than 5 includes 3 and 2 and 4. So that makes sense to shade in between. There are no numbers on the outside here that are meeting both criteria. So yes, this value of 6 is greater than 1, but it's not less than or equal to 5. It has to match both of the things that were given in your solution here. Something that's nice about the way that this one is written out is where the x is. See how the x is in the middle? That means that x is between those two numbers. So it kind of gives away the shading right away without even worrying about any of this off to the side. But it's just, I wanted to show you that so you have an idea of what's going on here. I hope that was understandable for you. Okay, you might see an example like 124 on a test or a quiz, but it's a little bit easier to understand with the way that it's set up. So this word or right here, I'm going to tell you right now, it doesn't mean you get to do one or the other. Or is part of the inequality, believe it or not. It's like this or that are possible. And the word or, I promise, will make so much more sense at the end. But for now, just take my word for it that we have to solve each of these separately. So you're given two different inequalities. You have to solve each of them separately. Okay, so I'm going to start with this left one. To get r by itself, I get rid of what's being added or subtracted first, which is that positive 12. So I get rid of it by subtracting 12 from both sides. Now this is definitely a weird scenario. It won't happen often, but those 12s on the left cancel. My r comes down, my greater than comes down, and these technically cancel too. But I need to put something there. So 12 minus 12, even though it cancels, Mathematically, 12 minus 12 is 0. Okay, for now I'm going to bring down the word or, and we're going to solve this next one. So I have a negative 4r is greater than or equal to 20. To get r by itself, it is being multiplied by a negative 4. Remember, when they're next to each other like that, it means multiplication. So to undo that, I'm going to divide both sides by negative 4. Anyone have that red flag sticking up? Okay, if you're dividing by a negative, you have to flip the sign. Okay, just adding to this already more little complicated problem. Okay, but dividing by a negative means flip the sign. So this greater than or equal to is going to become a less than or equal to. Okay, right here my negative 4's cancel and I'm left with an r. And on the right side, 20 divided by negative 4 is a negative 5. Okay, so your final answer for this is actually written out like so. And I told you I'd explain the word or. I'm going to do that with the number line. So when I go to graph this, your two significant numbers you need on the number line are negative 5 and 0. So I'm just going to do negative 5 through 0. Remember, 0 is bigger than negative 5. Okay, once you have your number line set up, you want to graph each one separately, kind of like we did in the last one. I'm going to start with r is greater than 0. So those two questions you have to ask yourself. First, is it an open or a closed circle? Hopefully you're thinking open. So an open circle goes around 0, and greater than means it's shaded to the right. So I know there's no numbers on my number line to the right, but numbers bigger than 0 would be to the right, so that's the direction I shade. Okay, next thing I have to graph is r is less than or equal to negative 5. So that one has the or equal to. So when I ask myself open or closed, that's going to be a closed circle because it's included. And it's a less than or equal to negative 5, which means I shade to the left. Notice if I didn't flip the sign, maybe I forgot, that means I would have my shading wrong too. You don't want that to happen. All right, here's the significance of the word or. Okay, notice where these are shaded. They're shaded in opposite directions. What that means is it's not like number 122 that we just did over here where like you have that and situation. This is an and problem where you can be greater than 1 and less than or equal to 5. Over here for 124, you use the word or because, like I said, it has to be one or the other, this or that. You can either be greater than 0 or you can be less than or equal to negative 5. There are no numbers at all, ever, that are bigger than 0 and smaller than negative 5. It's impossible. So that's why they're shaded away from each other. All or problems are going to be shaded away from each other, if that helps give you a little bit of a hint, because again, it's impossible to have the overlap like we had in the last problem with an and. Ors are this or that. Okay, if you have any questions about anything we went over, please feel free to reach out and email me or meet me on office hours to ask